acid-base titration. The end goal of our lab work for this adventure will be to determine the percent of KHP in a mixture. KHP is our source of the hydrogen ion for this lab, and you will create and then standardize a sodium hydroxide solution. So to dig in, you're going to follow the lab guidelines and measure out the amount of sodium hydroxide explained in the lab, add that solid to a reagent bottle, and then add pure water until the neck starts to form on your bottle. Then screw on the lid and just give it some agitation. You'll be able to hear the solid sodium hydroxide crystals kind of moving around. Then you know it hasn't been dissolved yet. Once you stop hearing the movement of solid, then carefully, and as always, you're encouraged to wear an apron and gloves if you would like. If you get some paper towel, and just make sure that in case this lid leaks just a little, you won't spill any. And so we want to make sure we get a homogeneous mixture of your sodium hydroxide. Sodium hydroxide is one of our strongest bases. We want to be very careful in its handling. If any spills, make sure that you rinse quickly, not safety shower worthy, but make sure that you're fully rinsing, wiping up any spills. We're creating approximately a 0.1 molar solution, but we are going to prove exactly what that is. This is going to be our titrant. So we will be rinsing our burette with sodium hydroxide. The burette will always hold this created solution. You are going to utilize a compound that we nickname KHP, but it is not solely made of potassium, hydrogen, and phosphorus. KHP stands for potassium hydrogen phthalate. We really don't need the formula. We need two things: the formula mass, which is given to you in your lab, and the mole ratio of the hydrogen ion that this delivers in solution with hydroxide, which is a 1-to-1 molar ratio. That's all that we need to know. What I would do is one partner, go ahead and make the sodium hydroxide solution. The other partner, go ahead and very carefully mass the 3 samples of KHP that you will then place into 3 separate Erlenmeyers. But of course, as always, you can utilize a beaker. I would just get one of the taller beakers to just help guard against any splashing when you're titrating. Usually Erlenmeyers are our go-to vessel. I would mark them just on the glass with Sharpie to designate the first, second, and third trial, or whatever you want to call it, A, B, and C. Then you can be sure that the mass you measured of KHP that you write down for trial 1 does indeed get delivered to an empty, clean flask. So we know the mass going in. Then you can calculate the moles, and then you know it's going to be 1-to-1 mole ratio when it reacts with the sodium hydroxide. The lab tells you to add enough water so that this will fully dissolve. Probably about 50 mils. If you want to add a little bit more than fine. We don't have to note the exact volume of added water because we've masked the KHP. KHP can just be a little stubborn at going in solution. So once you've measured the KHP solid, added the distilled water, if you want to add your stir magnet and then allow the stirrer to go ahead and assist with then the dissolving process while you're making the second and then third. Totally up to you. All right, when you have the sodium hydroxide solution fully made, we need to rinse our burette. And remember, in chemistry, rinsing hardly ever means using soap and water. So what I would do is open my valve and over the sink drain out all, it should just be holding pure water. Then, and it's up to you, if you feel okay pouring right from the bottle, but of course, if you want to get another beaker, and I will label this with my sodium hydroxide, and then pour from this, but I'm gonna make sure that my spout is closed. Now, because we know our solvent is water, and because of the great particle attraction of water molecules for each other, you're going to need probably a height of about 8 to 10 centimeters so that the force of gravity can overcome the particle attraction between the water molecules, and whenever you open your spout, it definitely will pour through for you. So I added about 10 mils or so, and then open the spout, and then I want to twist this, being sure that the sodium hydroxide comes into contact with every surface within the burette. And then I will go ahead and dump that out. And I need to do that 2 more times, 2 more rinsings. Then I'm ready, depending if you pour from the bottle or from your beaker. And I have not been blessed with great height. So I know I am not going to fill this all the way up to the top because I need it to be on eye level to appropriately read. You can always add more. And as always, if you feel more comfortable utilizing a funnel at the top, and go ahead and pour in or take out to pour just from your hand. But no matter what, okay, I have a waste beaker. I'm gonna put W on it just so I know this is my waste and not my solution that I created. I wanna make sure that I pour through the spout to make sure there's a consistent liquid column when I go to read my volume, and not an air pocket or any air bubbles. Now, feel free, this burette clamp does rotate. You just want to make sure that it never becomes loose enough that of course it will fall and then break your burette. So always just give it a little bit of a tug. But you can rotate this around, especially because you are going to titrate your sodium hydroxide into your KHP solution. And it can just get a little tricky positioning this with the stir if you're using that. So I want to make sure that my stir bar is centered. It will be stirring the KHP solution. I have filled this, but then drained the spout. And before I do anything, before I start my titration, I want to make sure that I add phenolphthalein to the acid solution. You know that you're adding a clear solution to a clear solution, and then you're making a salt, which is colorless, and more water, colorless. So you won't get any kind of a visual cue when you've reacted all of the acid away. So we want to make sure that we are adding, and you do not need any more than 2 or 3 drops. That is it. Because often we need to be very careful that we've measured the volume of our analyte, and if we add too much indicator, then we're throwing that volume off. So 2 or 3 drops is plenty. Then I would lower this very carefully down, and it's nice and comfortable for you. Before you begin adding the sodium hydroxide, you need to make note of that start volume. You can start wherever you like. You don't have to start on a whole milliliter. Make sure you are reading to the full place of precision that your burette allows you to. Then once you begin titrating, your eye is on your solution and the reaction vessel. Now, the KHP solution is acidic, and we know phenolphthalein is clear in the presence of hydronium in solution. However, it is deep pink in presence of base or absence of hydronium. Hydroxide is abundant. So you are going to note, and I have an additional video showing you this, that as you're reacting away more and more and more of the acid and the concentration is lowering, then some pink is going to start sticking around. Now, not this dark pink, but pale pink. So that is telling you, you need to slow down a little bit and maybe go from a stream of base that you're adding to just fast drops. Then when that pink sticks around, you want to stop your titration when it's the palest of pink, and that pale pink remains for 30 seconds. This isn't bad, but I wouldn't call this pale pink. I'd call this pink. And of course, we don't want to get into the magenta realm. We want to stop our titration when you have just added enough base by 1 drop that all the acid has been reacted away. So we want the lightest of pink. And as long as that remains for 30 seconds, you are good to go. So then you'll note the end volume. Be nice and patient with your first trial, because completion of your first trial can be used to inform the second and the third. So if it took 15.72 milliliters for your first trial, if you added about the same mass of KHP to your second and third, it should take around about the same volume. So you can quickly add maybe 12 milliliters, but then I'd go slow as you're getting closer to that 15, because we just want to be careful with every try. What you should do then is, knowing it's a 1-to-1 mole ratio, if you know the volume of sodium hydroxide and you know the mass of KHP, you can get the moles of KHP, and then you know it's a 1-to-1 ratio of KHP to sodium hydroxide. Knowing the volume of the sodium hydroxide, we can calculate with correct sig figs the molarity of the sodium hydroxide. You did 3 trials, you should get 3 molarities and then average those. That is best practice, not averaging your volume. You will average the molarities. Then that is the molarity that you have standardized, you have proven through a reaction. If we measure the mass of sodium hydroxide, add it, and make a solution, can we be very sure that all the sodium hydroxide from the weighing tray made it into the bottle? Also, sodium hydroxide is hygroscopic. It absorbs water from the environment as it sits. So even as you're carrying it from the balance back to your station, it's increasing in mass, or it may have increased in mass and gained water, and reacting it to determine the concentration of the sodium hydroxide is the better way to go. Then, once you've standardized and determined the sodium hydroxide concentration, also sometimes if we mass, just a side note, it can limit our sig fig. So if we do the reaction, that is definitely the way to go. Once you've standardized this, then we can use this to determine the percent of KHP in this mixture. The KHP is mixed with another white crystalline solid. They look the same. This is pure KHP. This is mixed with another solid that will not react with the sodium hydroxide. So the only thing that will react in this is your KHP. Now, we know the blunder we can make with titrations. So you probably, as a good scientist, want to complete analysis of this in 3 trials. Also, you can shake this all day long, but it's very unlikely that this entire sample is homogeneous. So if you separate this into 3, how do we then determine what data do we need to collect, knowing the concentration of this, knowing the reaction that's going to occur? How do we proceed to do 3 trials to then deliver the percent of KHP in this individual mixture? You want to do good thought and know what data you need to collect before you act at all in lab, because you could take a step that there's no turning back from, and then you have to start again. Every vial contains a different percentage, so it's individual for your group. Acid-base titration, your challenge is to be patient and to get just that pale pink that signifies your stoichiometric point, to remember to wash your burette, just good chemist practices. Be careful to give thought as to how you're going to collect your data and what data you need to collect to determine the percent of KHP in a mixture with an acid-base titration.